Yes, sir.
Yes, sir. This past weekend, we've been contemplating a maintenance repair procedure that involves soldering operations. So we have our maintenance glove box available along with our soldering iron, and that spawned this version of Saturday Morning Science. And what we're doing here is we're going to make our standard thin film where we have a 50 millimeter diameter wire loop, and we're going to pull the thin film by placing our two-dimensional beaker, which is our Ziploc baggie, over the film. And here we have the film. It's got some small bubbles in it. And what we can do now, and remember we've got the soldering iron out, and we've got our maintenance work area out. So I'm going to look at Marangoni convection driven by the tip of the soldering iron. And a few weeks ago, we investigated Marangoni convection where the heat source was a flashlight, and it would drive small convection patterns within one of these thin films. But here, with the hot tip of the soldering iron, you can see you get rather rigorous convection patterns develop right away as soon as the tip of the soldering iron goes into this water film. Our maintenance work area glove box is a really nice facility. It's a clear plastic tent with these tent poles that kind of pop up, and has glove port. Allows you to do operations like soldering without having to worry about fumes and with hot blobs of solder floating around. So here we can use our soldering iron with small quantities of water safely and not have to worry about getting hot water around. And here's a close-up of the tip, and you can see the little air bubbles in the water convecting around due to the surface tension-driven convection caused by the hot tip of the soldering iron. And these convection patterns develop almost immediately upon the heat source being added to the water, and they're quite rigorous convection cells which stir the film intensely. And now you can actually see little gas bubbles forming on the tip of the soldering iron as the water starts to heat up. And the convection is sufficient to pull the bubbles off of the tip and keep a fresh supply of water flowing across the tip of the soldering iron. Now, when you devise a series of observations like this, you like to keep the geometry simple so that you can describe what's going to happen with easier mathematical equations. And with the tip of the soldering iron leaning over like this in the water, it makes rather difficult geometry to analyze. So later on, we will keep the soldering iron perpendicular to the film. Here you can see in the film, full rolling boil has developed, and you see gas bubbles forming at the heated surface on the barrel now of the soldering iron. And the bubbles are expelled from the surface by the convection that's developed within the film, and new water circulates around and gets heated. And I found this quite amazing because the first order, the boiling process here, does not look that much different than the boiling you see on the bottom of your pot in the kitchen at home when you're trying to cook dinner. And there, gravitational-driven buoyancy supposedly is what removes the bubbles from the heated surface, and the buoyancy-driven convection driven by gravity keeps things stirred around. But here we do not have any of those forces available, and other forces spring forth and take the place and cause convection to occur in a manner that that the first order, not that much different than what you would see on the ground boiling water in a pot. And again, the quantities of water here are just a few milliliters. Now here, the barrel of the soldering iron is held perpendicular to the film, and the tip is plunged straight through the film so that you have the nice cylindrical geometry of the barrel heating the film now, and you don't have the complications of this conical point with a screwdriver blade tip. And the diameter of that barrel is about 8.5 millimeters, and the whole diameter of the film is 50 millimeters, and the thickness of these films ranged in the 2 to 3 millimeter thickness. Here's a slow motion of the tip penetrating the film. And you can see that surface tension forces through contact wetting angle distort the shape of the film and pull it up onto the barrel of the soldering iron. Here's the same thing in real time. Now, here, a small amount of water, a few milliliters of water was just squirted directly onto the end of the tip, or the barrel of the soldering iron, excluding the tip. Again, so you have a little easier geometry to deal with. And you can see the process of a rolling boil develop, where first you start off with small gas bubbles. They become convected away from the surface of the heated surface and move off into the volume of the liquid. And again, the surprising thing to me about this was the first order doesn't look that much different than boiling occurring in the forces involved for boiling on Earth require the gravity terms that are used in the equations to analyze it, or whether it can occur without the benefit or without the need of gravity when you're looking at the fate of the bubbles right near the surface of where the boiling is taking place. Certainly, when bubbles get expelled from the surface and are within the volume of the fluid, the gravitational terms are significant at that point. But if you're looking at the fate of the bubbles right next to the surface, perhaps there are other forces involved that are more significant than gravity. This is about the largest quantity of water I wanted to deal with. It's a few milliliters on the end of the soldering iron, and again, we can watch as it developed into a boil. Sometimes one of the benefits of doing observations in reduced gravity like on space station is that you can remove the effects of gravity So a process which it may be common on Earth has gravitational forces involved, and you remove the gravitational forces, and you can see what the process would be like without the gravity-driven forces, and this is a good example of that. And the surprising, the thing that just surprised me about this was how the boiling process appears to be almost like what you would see on the ground. We also have thermal gloves available to put over the standard gloves that are in the glove box. So your little piece inside the glove box can be protected from these hot solder or the hot tip from the soldering iron.